Okay, we're going to talk about X and Y intercepts. Just want to make a quick video on this. We're not going to talk too much about X and Y intercepts tomorrow, but we will on Thursday. You'll have an activity on Thursday going over X and Y intercepts. So you'll need to know this information. So I would watch this video tonight if you're watching it on Tuesday, and then watch it again tomorrow night on Wednesday so you're refreshed for Thursday, because Thursday will not be here to help you. Okay, so a lot of this is going to be review. We already know that in our slope-intercept formula, line, y equals mx plus b. Okay, we know m equals slope, and b is your y-intercept. Okay, we're going to go into more detail on your y-intercept, what that is, what that means, and what that does for you. I know that initially we started calling it the initial value. Now we're going to move away from that and we're going to call it the y-intercept. Okay? So, B is the y-intercept. Now, it is where, okay, and if you're taking notes, which you should be taking notes, the definition of y-intercept, it's where your graph crosses the y-axis. Okay, and if you remember, the y-axis is the horizontal axis, so it's where your graph crosses the y-axis or the horizontal axis. Okay? Now, here's the tricky part that students have. The coordinates of a y-intercept are always 0 for x and whatever your b value is. Remember, this is x and y. X, y. So when you have a 0 in your x coordinate, then the other number in the y coordinate, okay, is your y-intercept. But the most important thing, write this down. Memorize this. When you have a y-intercept, 0 is always the x value for your y-intercept, no matter what. Every y-intercept has a 0 for the x-intercept. That is has a 0 for the x-coordinate. That's extremely important. Okay? Always 0 right here. Write that down. Okay. So that's the basic information for y-intercept. Now, let's talk about the x-intercept. Okay? Y-intercept is easy to identify with your y-intercept whenever you're dealing with y equals mx plus b, because b is your y-intercept. But when we're dealing with x-intercept, it's not as easy to see. So again, this is x-intercept. The definition of x-intercept is where your graph crosses the x-axis. Where your graph crosses the x-axis. That's the definition of your x-intercept. Okay, very similar to your y-intercept. In this case, you always have an x value, and your x-intercept has a 0 for the y. Okay, we've talked about this already. With your y-intercept, your x is 0. With your x-intercept, your y is 0. They're like opposites, independent and dependent. X independent, y dependent. X input, y output. Okay, they're almost like opposites. So when I have a y-intercept, my x is 0. In this case, when I have an x-intercept, my y is 0. It's very, very important that you understand that. Knowing this right here will be able to help you identify x and y intercepts so quickly, especially from a table and especially from coordinates, so that way you don't have to graph everything. That's huge, okay? Now, when you're talking about x-intercepts, we also call these zeros. An x-intercept is also called a 0 or zeros of a function. Okay, that's another name for these. If somebody asks you to find the zeros of a function, okay, they'd be asking you to find the x-intercept. Now, we don't use this terminology a lot with linear equations in 9th grade, but we use the zeros of a function when we're talking about quadratics. So that'll come back a lot more in quadratics, also called roots in quadratics. We'll talk more about that later. But just know they are the zeros of a function. Okay? And again, it cannot be found in y equals mx plus b. I'm going to write this up here. Y equals mx plus b. There is nowhere in here to find the x-intercept. No x-intercept. Because we know the y is dependent, we know the m is the slope, we know the x is the independent, and we know the b is the y-intercept. There's nowhere to look at that form and say, oh yeah, there's the x-intercept. You can't do that. It doesn't work. Okay, so let's look at a couple examples here. Actually, we're just going to look at, we'll look at 2 quick examples. Okay, so if I have a graph, okay, so here's my graph. If I draw a line, here's my linear equation, or my line. This is my function, okay? Notice how it has 2 arrows at the end and it goes on forever. This is not a line segment. We do not deal with a whole lot of line segments in 9th grade. You need to stop making line segments and make actual functions. So here's my function. If I'm looking for my y-intercept, I go to my y-axis, and on my y-axis, I'm going to circle it. That is where the graph crosses the y-axis. Here's the graph. It crosses the horizontal axis right here, or the y-axis right here. So right here, my b, my y-intercept is b. b equals 1, 2. So b equals 2. The ordered pair for that, if I wanted to write an ordered pair, would be at 0 over on the x, up on the 2, on the y. Okay? Now, if I want to find my x-intercept, okay, I'm going to see right here, where does my graph cross the the horizontal axis? Where does my graph cross the horizontal axis? Right here, I'm going to plot a point, or I'm going to circle my point right there. So my x-axis is, my graph is intersecting or crossing the x-axis right here at -1. Okay, or if I wanted to write an ordered pair for that, it would be -1 over and 0 up. Okay, notice how y-intercept has a special name of b and the x-intercept does not, and that's okay. That's okay. Y-intercept is labeled by b, x-intercept is just usually labeled by x, or the x-intercept is. You would write all that out. Okay, let's do one more example. Okay, if I want to find my y-intercept, again, I'm going to go to my vertical axis. Where is it crossing my y-axis? It's crossing my y-axis right here. I'm going to circle it. I'm going to find out what number that is. 1, 2, 3, 4. So here, b equals 4. If I write an ordered pair for that, it would be 0 over 4 up. Okay, let's look at the x-axis. Here's my horizontal axis, my x-axis. Where's the graph crossing my x-axis? Right here. There's my x-intercept. It's not quite to 3. It's almost 1, 2. Let's just call it 2. We'll just call it x equals 2.75. I don't know. I'm just guessing. Don't worry about it. It's not a big deal. If I write an ordered pair for that, it would be 2.75 over and 0 up. So that's how you identify your x and y axis. Hopefully that clears up some things. I'm sorry, x and y intercepts. Hopefully that clears up some things. So take a look at it real quick. Make sure you completely understand it. Okay, I'm going to show you one last thing real quick before we wrap up this video. Let's say I'm given the equation y equals 2x plus 3. I want to identify 3 things. What is the slope? What is the y-intercept? What is my x-intercept? Okay? Two of them are very easy. What is my slope? What is my m value? Well, if this is y equals mx plus b, my m value is right here. So my slope is 2. Please notice, not 2x. It's just 2. Okay? My y-intercept, well, that's my b. My b value is right here, so my y-intercept is 3. Okay, here's the tricky part. Okay? Where is, or how do I find the x-intercept? Well, this is going to be difficult for a couple reasons. If you don't remember how to solve equations, or you haven't been exposed to solving equations, I'm just going to give you your first sneak peek of it right now. Okay, so just kind of watch and learn and write some information down. Hopefully you'll remember it when we get really in depth on solving equations. But this is what we're going to do. We know that every x-intercept has a y value of 0. So hopefully maybe some of that's clicking into your head right now. You say, oh, okay, I can replace my y value with 0. And so now I have 0 equals 2x plus 3. If I only have one variable, I can solve for that variable and figure out what the x is. And by solving for this variable, it will tell me what my x-intercept is because the x is the only thing left. When my y is 0, whatever my x value is, that's my x-intercept. So to solve this, I'm going to draw a thing called the river. I've got to get everything on the other side of the river, okay, away from the x. Well, I'm going to do the opposite. Well, this is being added to this, so I'm going to subtract it. Subtract 3 from both sides. This cancels. 0 minus 3 is negative 3 equals 2x, because that's all that's left. This is being multiplied now. 2 times x. I got to get rid of that 2. I'm going to divide both sides by 2. This is going to cancel. That's going to leave me with negative 3 over 2 equals x. So my x-intercept is negative 3 over 2, or negative 1.5. Okay, so that's just a brief introduction on x and y-intercepts. That's pretty much all you need to know. If you watch this video and you memorize this video and all the information from the very first part of this and how to find your x and y-intercepts on a graph, how to understand that x-intercepts have 0 for y value, y-intercepts have 0 for x value, then you'll be good to go on x and y-intercepts. It should be a very easy concept for you to remember. So go ahead and watch this video, save it, watch it again if you need to. We're going to really hit this information hard on Thursday. Also, we're going to get into something called direct and inverse variation. We're going to talk about direct variation tomorrow. I'm telling you this right now because I'm going to put a PowerPoint video. Again, this is direct variation. I'm going to put a PowerPoint video on direct variation on Blackboard either tonight or tomorrow, just to kind of have you review, okay? We're going to hit this topic. It's a very simple topic, but I need you to go ahead and review that and have that video and notes for you, okay? If you have any questions, jump on Edmodo as always and send me any information that you might need. All right? Good luck. See you tomorrow.